about an introduction to machine learning. It will be presented by our friend Ayoub from Morocco. He is a data scientist at Omdena. So with the pleasure to have you on board, Ayoub. Please try to start your presentation. And thank you again for being with us.
Thank you, Hera. With pleasure.
Thank
you.
So please go ahead, okay?
Sure. It's okay. I will start. Well, good morning, everyone. Thank you for coming, and we'll start our workshop. Well, this is an introduction to machine learning with the PyTorch or TensorFlow. So today in our agenda, we'll be talking about what is machine learning, the types of machine learning, how machine learning works, also what machine learning use cases are used in the field, and we'll be getting started with some tools of some popular tools that we use in machine learning, and finally a demonstration on how to build a machine learning end-to-end. Well, first we'll talk first what is machine learning. So machine learning is a branch of artificial intelligence that enables computers to self-learn. So from training and data and improve over time without being explicitly programmed. So machine learning is a branch of artificial intelligence which is introduced in the 1950s, and from evolution to which evolved into the 80s. Also, machine learning algorithms are able to detect patterns in data and learn from them in order to make their own prediction. So, in short, machine learning is algorithm and models are learned they learn from experience. While artificial intelligence and machine are often used interchangeably, so they are a bit confused, but they are two different concepts. First, AI is a broader concept which envelop the machine learning, making the machine making decisions, learning new skills, and solving problems a similar way to humans. So, whereas machine learning is a subset of like I said, a subset of intelligent artificial that enable an intelligent system to autonomously learn new things from data. So instead of programming machine learning algorithms to perform tasks, you can feed them examples of library data, which are known as training data, which help them make calculation, process data, and identify patterns automatically. So I'll be going now to the types of machine learning. Well, in machine learning, there are many types, like supervised learning, which is a field where we input example, we give the machine examples. There are the other one, which is unsupervised learning, where we don't know the data. So the data exists, but we don't know which the labels. There are also semi-supervised learning and reinforcement learning. So to understand that, how machine learning works, you will need to explore different machine learning methods and algorithms, which are basically sets of rules that machine learning use to make decisions. So like you see in the right, the machine learning is divided into three or four subcategories, like supervised, which we can use like classification or regression. Unsupervised learning, we can use clustering, dimension reduction, And reinforcement learning, we have many algorithms or methods. So we start with the supervised learning, which is supervised learning or algorithm or models make prediction based on elaborate learning data. So we feed the machine with the labeled training data. Each sample includes an input and a desired output. A supervised learning algorithm analyzes these sample data and makes an inference, basically an educated guess when determining the labels for unseen data. Like I said, the subcategories of supervised learning, there are regression, which have some algorithm like regression, linear regression, multilinear regression, or also polynomial regression. For the classification, there are many algorithms. We can say like, for example, decision tree, Canier's neighbors, logistic regression classification, or naive Bayes, or SVM also. There are many algorithms in this subfield. Let's go for the unsupervised learning, which are uh, uh, which are algorithms that uncover insights and relationship in unlabeled data. So we don't know the labels of the data that's given to us. In this case, models are fed input data, but we desire outcome but the outcome, like I said, are unknown. So they have to make inference based on circumstantial evidence without any guidance or training. These models are not trained with the right answer. So we give them the input, but we don't know the output. So they must find a pattern. For example, we have a box which contain many fruits like apple, bananas, lemons, but we don't we get them without knowing them by sight. So, but the algorithm try to label them, to try to categorize them into apples, lemons, and bananas like this. So there are in this algorithm there are clustering, which are you can find k-means, which is the basic algorithm in clustering, PCA or SVD. There are also association analysis like a priori or FP groups, or also there is the hidden Markov models. The first one are continuous, or the other one are categorical. Like I said, there is a subfield like semi-supervised learning. In this case, the training data is split into two, like training a small portion of with the human-made labels, which is labeled data. So it's a small portion of labeled data, and a lot of unlabeled data. So the first classifier is the base model. The second one is trained on the labeled data, and we try to give them an inference, to give the prediction. The model uses labeled data as an input to make inference about unlabeled data, providing more accurate results than regular supervised learning. Well, this approach is gaining popularity, especially for tasks involving large data sets, such as image classification. So, like for example, we have an image classification. Like if we want to identify image face dissection, or we want to classify the image of animals, of flowers, or something like that. So we use this type of machine learning, which is semi-supervised. Finally, there is the reinforcement learning, which is concerned with the how software or an agent how to act in a situation to maximize the reward. In short, reinforcement learning models attempt to determine the best possible path they should take in a given situation. So this type of machine learning, we use it like in autonomous vehicles. We are try to, for example, can give you the example of Tesla. You know the models of cars of Tesla. They can drive autonomously. So this is the type of they use to the to train and to give the car how to drive autonomously. So in order to do that, they try to give trials and reward the car with some points. Since there is no training, data machine learn from their own mistakes and choose the actions that lead to the best solution or to maximize the reward. There are many models in this reinforcement learning, like policy-based or value-based. Also, they learn from quasi-model based also. So this field of reinforcement learning is a broad field in machine learning, which is used daily in our lives. Well, to give a, we can, like you see in the first GIF in the app, there is a character which is like a human character, and we give him a reference motion, so he can do the like a kick or a karate kick, and the target is given in the above. He can give a kick to a ball or something like that. So if he kicked the ball, we give him a reward. If not, we give him like we substitute a point or something like that. Also, the example in the above, when the player jump off the wall, we give him a reward +1. If not, the game is over. Well, how machine learning works. Well, in order to understand how machine learning works, first you need to know what's a tag or a label, something like we can say it is a tag or a label. For example, if we want to train an image recognition, for example, you would tag the photos, like for the example in the right, we want to classify if the image is a cat or a dog. So we are given some tags, like the tag is the label, which is dog, a dog or cat, a horse, for example, the animals with the appropriate animal's name. This is called data labeling. So we give a set of data, images of dogs, images of cats, images of horses, images of multiple animals, and each type of animal we give him a name, like dog, cat, horse, cow, and so on. So we label the data, give them a tag. So like you say in the right graph. So first we go with the training. So we give this is an example of sentiment analysis. So we give we get a text which will target with each if it is a positive or neutral or negative. Then we get some feature extraction. We get the feature extracted from this text, and we apply some training in it with the model, with the machine learning model, supervised one. Then we get our model trained, and we try to test it on some new texts. I will share with you an example. Can you see the Khair, can you see the pressure?
Not yet, Ayoub.
And now,
Yes, it is now appearing.
so I will. This is a sentiment analysis, which is foundation online. So we'll try to test it. For example, this is a good day. So the tag which we have is positive or negative or neutral. So we'll try to classify this text, which is this is a good day. So it give us a positive tag with a confidence of 99%. Let's try another example. So we give it an negative one. It will give. So it gives us a negative tag with a confidence of 80%. So like I said, we give the texts tags like positive, neutral, or negative, and so we get we extract feature and all, and train the model and test it. So this is the basic machine learning, how it works. So we feed for a first step, we feed the machine learning model training with input data. In our case, we could tweak consumer comments from social media or customer service data, just for like the example I showed you now. We can get this data from like Amazon or any social media. Secondly, the text training, we try to level our data with the desired output. In this case, tell your sentiment analysis, like whether the comment or the piece of data is positive, neutral, or negative. Then the model will transform this training data into text vectors, which are numbers that represent the data features. So this text will be going to be a vector with a representation of each word or each phrase. Finally, we test our model by feeding test data, like some unseen words or unseen phrases. The algorithm will be trained to associate future vector with text based on the manual target samples, then to learn make prediction when processing unseen data. So this is the basic how machine learning works. So now we'll jump up to the use cases of machine learning. Well, there are many use cases of machine learning and data science in the nature or in the field. So I get to you some the top 10 of these cases, like the healthcare, for example, patient diagnosis, in the finance, like fraud detection. We'll go to like the field of manufacturing to detect anomalies in production. For example, retail inventory optimization. So how to optimize your inventory. The use case for government, well, like smart services, like getting new portals for the daily services in the government, like the transportation, for example, like the service of Uber or Lyft or something, or Kareem or something like that. So we forecast the demand of a passenger. The field of networks, like intrusion detection, if someone intrude your service or your network. Like also in e-commerce, like system recommendation. So how we recommend products or for a new customer. Also for the field of media, like the interaction of and speed, how to improve and or boost our interaction and speed in social medias. or the field of education, like giving some research insights from the cases of education, if the education is going up or down, something like that. So there are many use cases. These are the top 10 I found. So to get started with the machine learning, there are many tools to use. For example, we'll go to use the open source libraries. Open source machine learning libraries offer a collection of pre-made models. There are some pre-made models and components that the developers can use to build their own application. Instead of having code to transform code from scratch, they are free to and flexible and can be customized to meet specific needs. So these open source libraries, they are pre-made, so we don't have to code it from scratch. Like for example, a scikit-learn, which has all the machine learning algorithm for supervised or unsupervised or reinforcement learning. There is the TensorFlow package, which is a library to use Tensor. I will explain them shortly. There is PyTorch, also a machine learning library. There is Kaggle, NLTK, and there are many more. So for scikit-learn, which is a Python library and a great one for those who are just starting with the machine learning. Why? Because it is easy to use and really it is easy to use, robust, and very well documented. So there is a huge community behind this scikit-learn. So you can find tasks such as classification, clustering, regression, and among others. So there is many others algorithm defined with by fields. So you can find clustering, classification, regression, and so on. For the TensorFlow, which is an open source library, also you can use it. Well, these libraries you can use it even with Python or with R or other things like which is depend on your the language you are using to program. Which is complete, which is developed by Google for internal use, and then afterward they release it under an open policy and open license with tons of resources, tutorials, and tools to help you hone your machine learning skills. Also, there is a big community behind this behind TensorFlow. This library will include pre-built and pre-trained models, so you can just import them and use them. TensorFlow is more powerful than other libraries and focuses on deep learning, making it perfect for complex projects with a large-scale data. So we can use it for machine learning, deep learning, and so on. Well, for PyTorch, which is a library developed by Facebook, it is also open source based on Torch library, which focuses on deep learning. Mainly it is used for computer vision and natural language processing, and is much better at debugging and some of its competitors, which are TensorFlow, for example, and Keras and other libraries. There is a great community behind it too. So you can find tutorials, you can find documentation, all you want to, and so it is very flexible with a high speed and ideal for a quick solution.
Ayoub,
yes.
would you permit me? Yes, just to say to everyone, we will have an interruption in about 5 minutes. Just try to reconnect on the same link and
Okay.
follow with Ayoub for the practical session, please.
Sure.
Okay? So
okay,
just
sure.
reconnect. Yeah.
Thank you. Sure. Like I was saying, Kaggle, which is also a platform which is launched over a decade ago, and acquired by Google in 2017. It has a philosophy of learning by doing, so you can log into Kaggle, start a project, do your machine learning, and share it with everyone. And the community can give you feedback if your work is going is great, or can provide you with some remarks and so on. Also, you can participate in competition for knowledge, or for with a cash in final. For NLTK, which is the natural language toolkit, is a known library, possibly the best one in for natural language. If you are trying to to classify text or something, if you are going to work with texts, it can be used for keyword search, tokenization, and classification, voice recognition also, to recognize our voice, with a heavy focus on our research and education. So also this library is have a great community behind it. So you will find many resources on this library. So we'll go with demonstration. Wait after the. So I will state the problem for this. For example, well, the objective of this example is you are in a hospital in the province of Greenland, which give you has trying to improve its care condition by looking at historical survival of patients. They tried looking at their data but could not identify the main factor leading to high survival. So you are the best data scientist in Greenland, and you are being hired to solve this problem. Now you are responsible for developing a model that will predict the chances of survival of a patient within for patient after 1 year of treatment. So the target, our output, it will be 0 or 1. If a patient is survived after 1 year. So the dataset contains the patient records collected from a hospital in Greenland. Like I said, the survived 1 year column is the target variable, which has binary answers 0 or 1. So we'll go to the notebook.
So we will try to reconnect now, Ayoub, please.
Sure. Okay, sure.
Yes. Okay.